We are live now.
Okay. All right, everybody. Thanks for being here today. We're gonna start our seminars again. The LAERE series. Today we're very happy we have Paula Pereda with us. Paula, she has a Ph.D. in economics from the University of Sao Paulo, and is an associate professor at the Department of Economics at the University of Sao Paulo. She was a visiting scholar at the Yale University from 2018 to 2019, and her research focuses on applied microeconomics and policy evaluation, mainly in environmental economics and health economics. And she has been publishing quite a lot recently, so she's really one of these young rising stars in the region. So we're very excited and very happy of having Paula with us today. So Paula, the floor is yours. Thanks for being here.
Thank you, Alejandro, for your kind introduction and for the invitation. I'll share my screen now. So do you see my presentation?
Yes.
Okay, great. So thank you again for the invitation. It's a pleasure to be here and this distinguished group of colleagues. This research is a joint work with Jaqueline Oliveira and Gabriel Monteiro, which was a former master's student of the University of São Paulo, and now is beginning the PhD in Carnegie Mellon. So the main motivation of this research is that climate is an important amenity and also very important for agricultural productivity. And in light of the predicted temperature changes that we observe, we conjecture that climate change might reshape the spatial distribution of the population and of the crop choices across farmers. So the goal of this paper is to quantify those phenomena. And when I talk about adaptation here, I'm talking about two mechanisms of adaptation, which are migration and the changing in crops. So we turn to the case of Brazil for some reasons. First, the country has continental dimensions, and climate diversity implies that the regions will experience climate change quite differently. In this figure, we can see for the high emission scenario of IPCC, the spatial distribution of temperatures in summer and winter across the country. And what we see here is that some areas won't expect much change in temperature, while other areas, for example, more central in the country, we will observe a high increase in temperatures in both seasons. And also, Brazil is an also interesting set because there is a considerable share of Brazil's labor force employed in the agriculture sector. So the share of agriculture on total employment has decreased over time, it's a fact, but it accounts for approximately 20 to 30% of total employment in Brazil. So it's still a large fraction of total employment. And here I'm showing two figures from data from the global agroecological zones, the GAES data, which shows agricultural yields in a scenario of high emissions in comparison to a baseline. The baseline here for this data consider the historical average from 1961 to 1990. And what we can see here, for example, for coffee and for wheat in Brazil, is that, for example, wheat will be, these are the agricultural yields, and wheat will be very negatively impacted by climate change, while coffee will be negatively affected in most of the country. But in those yellow areas, we can see an increase in the land suitability for this crop. So in light of this context, we propose to investigate the impact of climate change on migration and crop choices, and we will account for the usual climate amenity. I will explain more about the model, but also this channel via the changes in crop choices. So what we do here, our framework of analysis is a spatial equilibrium model of the Brazilian economy. We divide the economy into two sectors, agriculture and non-agriculture. We model crop choices in the agricultural model using farm gate prices and land productivity. And when it comes to labor markets, here we consider that workers, they choose the city in which to live based on wages, on housing costs, and the amenity values, which can be climate and non-climate, I will explain later, and a taste parameter. And we allow for labor market frictions by assuming that migration is costly and depends on the distance traveled. I have a paper working on that with Jaqueline Oliveira, which is also a co-author here. And the individual's location decision here determines the labor supply to each city and its model using discrete choice techniques. When it comes to the climate change channels, the climate change here impacts the city amenities and the crop productivity. So, and crop choice also affects wages in the agriculture sector and land prices. And in our model, wage and rents, they are endogenously determined by the equilibrium in the labor and in the housing market, which means that our framework allows to estimate welfare effects while accounting for equilibrium impact on markets for labor and housing. So after we estimate the parameters of the spatial equilibrium model, we'll be ready to quantify the effects on the crop spatial distribution, on agriculture employment, on internal migration, and on the regional distribution of population and welfare. I didn't bring the welfare effects here, but they are available in the first version of our working paper. So just to get a sense of our results, what we find here is that migration, due to climate change, migration increases on average 16%, while the agriculture employment share decreases by 20%. We observe huge regional inequalities in our results. For example, the North and Northeast regions. So Brazil is divided by macro regions, which are the North, Northeast, the South, Southeast, and the Midwest, which is in the center. And the northern areas of the country, which are the less developed regions, we lose population. Yeah. Any question? Sorry. So what we find here is that the northern areas, we lose more population than the southern areas in the country. And I just highlighted here some examples of the changes in the crop choices. So for example, the coffee land share will decrease in the northern areas and increase in the south, while the maize land share will increase in the north and decrease in the south. And we also find that the crop choice channel that we added here in this paper does not mitigate migration and sector responses. It has a small effect on agriculture employment, and I'll show you. Okay, so about our spatial equilibrium model. First, I'll show the model in terms of the labor demand in the agriculture sector. So we consider two sectors, agriculture and non-agriculture. Agriculture here is R from rural, and non-agriculture is U from urban. So we consider the location. We assume that the technology to produce a crop M in a parcel of land omega depends on labor, which is N here, and land. so two inputs, and it's a technology that presents constant returns to scale. The suitability of a plot, omega, is captured by a TFP A, which follows a Fréchet distribution with parameter theta. And this TFP, this land suitability, it's an average land suitability for crop M across all plots. And if this land suitability increases, it suggests that high land quality for every plot in location K is observed for growing a crop M. So within a region K, the variance, so the between plot variance in land quality decreases with theta. So theta can be interpreted as an inverse measure of land heterogeneity. So the higher the theta, the more homogeneous the location KE is in terms of the parcels of land. So the representative agricultural firm in location K hires labor and rents land, and the farmer decides how to allocate plots of lands across crops and chooses the amount of labor employed in each plot. So given the profit maximization and our distributional assumption on A, the land allocation across crops in location K at time T is given by this equation. So the eta here is the share of land in K allocated to crop M, and it increases with the crop prices P, and which the increase in average land suitability of crop M at location K. So the equilibrium wage in the agriculture sector in location K is described by this equation 2, and the wages in the agricultural sector, so they relate to the labor. So sorry, somebody's with the mic open. Sorry, question. So the wage in the agriculture sector relates to labor demand, to land use prices, to productivity, and to land share for each crop. When it comes to the labor demand for the non-agriculture sector, the non-agriculture firm uses only labor as an input, so the production function is defined by this equation. And we divided the productivity term here into a location-wide determinant and a location sector-specific shock. So wages in the non-agriculture sector will be determined in a competitive market, and this is the equation of the equilibrium. When it comes to the location choice, we model the indirect utility function of worker N, who starts the period in CDJ and moves to CDK to work in a sector S. And so these individuals, they observe the wages, which are sector specific, and the housing costs, so the wages W and the housing costs R. And the individuals that they pay a spatial migration cost mu, which we model by a fixed component and a variable component that depend on the distance between regions J and K. And before choosing a location, a worker draws a taste shock, which we also assume that follows a Fréchet distribution with a parameter sigma. So the likelihood that a worker migrates from J to K to work in a sector S in a period T is given by this expression, and I'll explain later how we will estimate this equation. So the housing market model, we assume that each location has a well-developed housing market Land is rent both by agriculture firms and individuals. Remember that when we model non-agriculture firms, we do not consider land as an input. And we use both the workers and the farm's demand for housing to set up the equation that characterizes the equilibrium, which is given by this equation. So a greater value, for example, of phi increases the effect of land rental costs on housing rents, and a greater value of psi increases the impact of housing demand on housing rental prices. So how does our model respond to climate change? So climate change here has a direct impact on climate amenities and crop productivity by using our TFP measure. So farmers respond to those changes by reallocating their inputs according to this new optimal set of crops for the new climate. Then we have changes in agriculture demand for labor and land that impacts agricultural wages and housing rental prices. And workers will evaluate their indirect utilities based on these new climate amenities, on the new wages and the new housing prices. And they will choose their location sector pairs, considering that migration is costly. And they will migrate when individuals migrate, wages and rents are adjusted by the local supply and demand, which further alter all locational choices, and a new equilibrium will be reached when no one has incentive to migrate anymore. So about our data, so we use the census data, the decennial population census from 1980, 1991, 2000, and 2010. The municipalities in Brazil, they are the smallest geographic unit for each data on economic variables are available. But then we group those municipalities into more than 500 microregions. The microregions, they are defined by specificities regarding the economic structure of Brazil. So the structure of agricultural, mining, and industrial production. So we believe that it's more suitable for the purposes of this study. And we also restrict our sample to workers aged 25 to 60. So working individuals. And what we observe in the census, we have information about the income from the main occupation and the total hours worked, so we can compute the hourly wage rate. And for those individuals that rent their homes, the census also collect information on how much they pay for those rents, and we compute this information. And we also observe information on the municipality of residence of the individuals 5 years prior to the census. So we use this information to compute the bilateral migration flows, which will be very important here for our estimates.
Excuse me, Paula, I'm sorry. There's a clarifying question in the chat. Sophie asks, how many sectors are there, and are they chosen simultaneously with locations?
Okay, so we have two sectors only, agriculture and non-agriculture. And what we observe here, we observe the sector of employment of the individual only in the destination location. Okay. So for the agriculture data, we use many sources. One of the sources, we need the agriculture data to identify the parameter theta, which is the land heterogeneity. And we use the 2006 agricultural census to calculate the farm gate prices, which are calculated by the production value divided by the production quantity. We also have information about crop yields and crop production areas. The 2006 agricultural census have information by 34 crops, and we select 18 of those crops, including the main crops in Brazil, like soybean, maize, and sugarcane. And these 18 crops, they represent 96% of total planted area in the country and 90% of total production. As I mentioned, the GAES data, the Global Agroecological Zones data, we use this source to get the land suitability for crops. So the GAES data, for those who doesn't know, it bases, it calculates a crop yield information based on agronomic models, and they calculate that for a baseline period from 1961 to 1990. So we use this information as a shock in our model. We also use data on agricultural crop revenue and land share from the Brazilian Municipal Agricultural Service. They are annual, those surveys. And we use this information to construct a shift share instrument here to estimate our theta. I'll talk about the endogeneity problems that we face here when we estimate our equilibrium equations. The climate data, so we're the GAES data also calculates the yields, the crop yields under future scenarios. So we use the future scenario, the Hadley Center scenarios here, and we are basically doing our calculations using the period from 2041 to 2070. And for two scenarios, the A2, it's a high emission scenario, and the B1, which is a less pessimistic climate change scenario. We have a historical daily weather information from INPE-CPTEC, and so we calculate 10-year average to use within the 10-year census, and we have information about temperature, about rain and sunshine hours. And we also have information about future climate forecasts from INPE under the climate change scenarios. Okay, so about the estimation of our parameters. So to estimate this land share elasticities, which is our theta using the crop share data, we cannot estimate this equation directly. So first we take a log to become more tractable. And we know that the farm gate prices, they are endogenous here. We have a simultaneity bias because if we believe that crop prices result, at least in part, from a local market equilibrium, then the land use will affect the quantity produced and also affect prices. So to overcome this potential simultaneity bias, we construct an instrument for agriculture farm gate prices. And this instrument, it's basically an interaction between the distance to the closest major port for agricultural products and an index of crop exposure to international trade, which is this IM. So to the distance to ports, we use the study from Neto from 2006 that they determine what are the major Brazilian ports for agriculture near the year of our analysis. And for this crop exposure to international trade, we gather data on exports and imports of the crops and its related products. We use the data from the Ministry of Agriculture, Livestock and Food Supply in Brazil. We use data for 2005 because remember that the data we have here to estimate is the 2006 agricultural census. So we use information from the year before to create this measure of international trade share by crop. And after that, we divide this international trade share by crop revenue to get a relative exposure to international trade, such that the crops with a greater index value of IN are the most exposed to international markets. So here I'll show the results of our first stage estimation. So the more exposed to international markets, the lesser the price. So it has a negative relation here. And our F statistic of the excluded instrument is about 30. And this is our second stage, our main estimation for our theta. So theta, if you remember, must be greater than 1. So we find a 1.12 approximately theta, which is a little bit lower than other papers have found. For example, the Sebastian Sotelo paper for Peru. But it suggests that in Brazil, we have a large heterogeneity within region and within crop, and a large heterogeneity in land quality in Brazil. Okay, so now to estimate the migration costs and the indirect utilities, first, we take the logs of this equation and from the pi, and we can treat this the denominator of this equation as an origin year fixed effect, which we do here with this this delta, and then we identify the indirect utility as a location sector year fixed effect. And we can estimate the migration cost, which is our mu, that, as I mentioned, we consider two components, a fixed effect component and a variable component from the distance between J and K. We estimate this equation using Poisson maximum likelihood strategy. And so we have here about more than 4,000 indirect utilities, because we have more than 500 microregions for 4 time periods and 2 sectors. And then we are able to estimate our Maize, which are the migration costs, and we save our indirect utilities to decompose later and estimate the sigma and also the amenity elasticities.
Sorry, Paula, before you continue, there's another question in the chat.
Sure.
Luis Quintero asks if climate change will come into play as a counterfactual after estimation of the model, right?
Yes, right, that's right. I'll just talk about the how we estimate our equilibrium equations, and then I'll say more about that. So here we are able to estimate our migration costs. So we have a high fixed migration cost and also a high variable component. So my moving is very costly in Brazil, which is something that we found in a previous paper, and other papers also find. So this is very important because these costs, they must be accounted for individuals when we calculate adaptation to climate change. So as I mentioned, from estimating the first equation, we have the indirect utility measure. And from our model, we relate our indirect utility parameters in relation to the wages, the rents, and the amenities. So we have climate amenities here. And we also have non-climate amenities and sector of employment amenities, but we do not observe those two. So we use macro region year fixed effects and meso-region trends, and also the agricultural dummy variable to control for that. And what we identify here, we also calibrate the lambda using our previous paper. And what we calculate here is the elasticity to wages and also the impact of climate amenities on the indirect utilities. So again, here we suspect that we might have endogeneity because a wage, our measure of wage growth is impacted by labor supply growth, which also is affected by indirect utilities via migration probabilities. So in order to tackle that, we propose here two instrument variables, a Bartik shock, which is also shift share instrument, very common in the labor literature. And we also propose a labor market access instrument. Also, we do not propose, we use from other papers that calculated that. So because migration costs implies that the labor supply to destination location K depends on the ease of access to that location, we compute this instrument as an inverse bilateral cost weighted average of the population in the origin locations in the previous period. So we use those two instruments here. When it comes to the non-agricultural wages, we restrict our data to non-agricultural workers to estimate the elasticity here. And we apply the log from our equilibrium equation and take the first difference. So here again, by estimating this equation directly, we would also incur in bias. So we also use the Bartik and the market access instrument here for our labor information. And lastly, the last equation how we will explain how we estimate is the housing prices. So here I'm sorry, there's a typo here, but we need to estimate here the phi and the psi. And we take logs from our equilibrium equation and use also first difference here. And we also have a bias here as the housing rents, they can impact via migration the local agricultural labor supply, which is also a determinant of both land rental prices and housing demand. So here we use two instruments. We use our instrument of labor market access measure, but we also propose here another instrument, which is this agricultural revenue shift share, another shift share instrument here that capture this exogenous growth in crop prices or in agricultural productivity for some crops in the baseline period. So this is the estimation of those three equations, considering the instruments. And what we find here, first, an increase in summer temperatures reduces the individual utility, while the winter temperatures that they are more perceived as a positive amenity. And also increases in wages also impact positively the indirect utilities. And remember that here we have two instruments, the Bartik and the market access. The second is more important here. We also estimate the non-agricultural wage equation and the elasticity here, which is also negative. So the greater the land supply here, the lesser the wages. And finally, we also estimate the housing rent elasticities to land of about 0.12. It's a little low in comparison with the literature, but it might indicate that a low importance of the micro regions land prices to the formation of housing prices in Brazil. So maybe because Brazil still have abundant land for housing development. So about the former question, so once we have the estimates of all our main structural parameters, we conduct our counterfactual simulations using this set of equilibrium equations. So we calculate the temperature changes from 2041 to 2070 to the baseline. So we update our climate amenity variable. We also use GIS data to calculate the change in the land suitability, in the change in the agricultural yields. And we update our measure of TFP. And based on that, we can calculate the new location sector choices, new crop choices, new prices, and new equilibrium until population converges, as I explained a little earlier. So these are the main impacts that we found for selected crops. So for example, maize and for coffee. In red, we have the decrease in the area of production of this crop, comparing the scenario with high emissions, so the most pessimistic scenario with the baseline. And in green, we have the positive affected areas. So we can see, for example, for maize, the northern areas will be more suitable for this crop. So the land share of maize increases. And for coffee, it's basically the opposite. So we observe a decrease in the suitability of land. So the land share will decrease in the center north areas of the country, while the south and the southern areas will be positively affected. I summarize here the effects that we found in terms of crop choices. So, for example, the crops that presented higher predicted increase here were cassava, bean, rice, and maize. And we had 3 of the main crops that presented a decrease in land shares, and they were sugarcane, coffee, and wheat. And so in general, we also find, in terms of crop choices, we also find greater changes under the scenario A2, which is the high emission scenario. As I showed you, maize will occupy the less cultivated area in the south macro-region of Brazil, while coffee is predicted to increase its occupation in this macro-region, which were the selected maps that I show you. Soybean is also predicted to slightly increase its occupied area in most of Brazil, while cassava is predicted to be more present in the south and less present in the north and northeast. So now I'll show the results in terms of migration and agriculture employment. So here we have the first line. It's the change in migration rate under scenario B1, which is a less pessimistic scenario, and A2, which is a more pessimistic. And what we find here is the change in migration rate when we allow crop choices, the changing crop, and when we do not allow crop choices. So we see that here, allowing the changing crops is not affecting much the total migration rate, but it affects more the agricultural employment. So when we chose this channel to change the crops, the decrease in agricultural employment is expected to be a little bit higher than when we allow farmers to change their crops. I also show here the same results, but now by Brazilian macro region. So here we have the north macro region, the northeast macro region, the southeast macro region, the south, and the Midwest. And I just highlighted here some results. So in terms of migration rate, what we observed is that the Northeast macro region, which is one of the poorest regions in the country, migration rate will increase a lot, and it will lose its population basically to the Southeast region, which is highlighted here in blue. A little bit to the south, depending on the scenario. In terms of agriculture employment here, we observe again that the North and Northeast regions, the agriculture employment will decrease, and the region that will increase its agriculture relevance is the South region. And here the crop choice channel was important to change the results. So if we allow farmers to change their crops, the effect on agriculture employment is positive, and when we do not allow this channel, the effect might be negative in the B1 scenario. So basically, these are the main results that we find. We find a spatial redistribution of crop land shares. So for example, coffee loses ground in the northern regions and gains in the southern regions, and the reverse pattern is observed for maize. We do not find much interaction between crop changes and migration effects. There seems to be some mitigating effect on agriculture employment, mostly in the southern region, as I showed you before. We also observe some regional differences that are very important. So the Northeast macro region is predicted to have the more significant increase in out migration rates and decrease in agriculture share of employment. And as Brazil is very big, and this is another example of climate change showing increasing the vulnerability of the economic vulnerability of regions. We observe many results on that in cross-country comparisons, but as in Brazil, we have a lot of differences between the regions. We can observe this here. There are some shortcomings from the modeling approach that we propose here. So, for example, our model ignores the impact of internal trade, also in mitigating those climate change effects that we find, and also on food prices. So this is a work in progress that we intend to improve the model on that. It increases a lot the number of equations and the problems of the simulations, but we have been working in this direction. So I think that's it. I had 45 minutes, as Alejandro mentioned, so I'm 1 minute before. Thank you. I'll just I'm available for questions due to this work in progress, and I also leave my email address here in case you need to exchange information. Thank you.
Thank you, Paula, for the very interesting presentation. I think there was a question in the chat. Luis, do you want to ask it yourself?
Sure. Paula, thanks a lot. This is a great paper and fascinating data. I'm wondering, so what I find the most interesting is this idea that kind of markets help us adapt to climate change, right? Because if we allow endogenous decisions by farmers, the effect on the sector is lower. So when it wasn't clear to me, when they make these decisions of switching to other crops that might be less affected, is this, affecting the price of the crops, or because it's agriculture, we assume like prices are exogenously determined by the world market?
Yeah, thank you, Luis. That's a great question. In the simulations, we keep the crop prices fixed. So this is something that this is one comment that we had in another seminar too, that we are working to fix. But yes, we do not model the changing prices here. But I agree with you that this is and actually it also, your question, it's very related to our ideas to increase the model with the internal trade channel, which is also an additional channel of how the market can help mitigating. In our paper from the GIM, the 2020 paper, we did some simulations on that, but they were very preliminary. And we also discussed how the partial equilibrium versus the general equilibrium effects, they differ. So also the fact that we use a spatial equilibrium model here, a general equilibrium model, also reduces a lot the climate change effects that we normally estimate.
Got it. Oh, you're already estimating, like your model already improves upon the, how realistic it is in incorporating multiple markets. So I hate to be asking for one more, but thanks for clarifying. No, it's really good.
Thank you.
Thank you. Is there another question? Anyone wants to ask a question? Go ahead.
So Juliana, sorry, if there's not another question, I had another question that I wanted to ask Paula.
Go for it.
Paula, so this decline in productivity is coming from just like the impact that climate change has on just the land productivity, right? It's not from workers suffering from extreme heat or anything like that, right?
Exactly. The GAIA's data, which is very interesting, by the way, they calculate, they have like a daily model that they call, it's a crop growth model. So they update, for example, the climate, so as the increases in temperature, for example, coffee, that is a crop that it's more used to temperate seasons. In the north, it will become much less suitable for the north of Brazil, because it will become very warm. So it's only land suitability itself, but it's a very interesting data set. And also you can choose there the use of inputs. So you have the option to calculate the model using an irrigation system or the rain-fed system of irrigation of crops. So there are some other papers that explore this use of inputs to discuss technology improvements, how technology improvements can help also to increase land suitability. I think that is a paper from a former student from the university, Heitor Pellegrina, that does that.
Got it. Thanks. Great.
Thank you. Paula, I was just wondering, you mentioned at some point that you estimated welfare effects. Can you elaborate on that? I mean, I'm curious on what you find.
Yes, welfare effects are always very difficult to I'll open here to show you what we had in our paper. Let me see here. I'll share my screen again. So is it too small?
It's okay.
It's okay. Okay. So here's the change in welfare that this is very preliminary, and I wasn't able to include here. but we can see a high decrease in welfare also in the north and northeast regions, and an increase in the southeast regions, especially in the high emission scenario, which is an increase, a more pronounced increase in temperatures. So it seems like all the welfare effect is going to the southeast and south region, which are the most developed in Brazil. So it's again another piece of evidence that shows an increase in vulnerability within Brazil.
I'm sorry to interrupt you, is the Northeast more vulnerable? I think you mentioned, but I'm not sure. Just wanted to clarify. More vulnerable, more agricultural oriented?
It's more agricultural oriented too, and also it's where the climate is already problematic. For example, we have most of the area in the Northeast is what we call the semi-arid, and it already has problems with the climate to produce. So of course in Brazil we have Embrapa, which is a technology agency that helps to improve the crop suitability in those regions, but still it's the region that has the lower income per capita in Brazil, the major inequalities, and it's the warmer region. So the Northeast is the warmest, and the North region where the Amazon forest is, it's also very poor, but the climate is a little bit different. It rains a lot there. It's very different from the semi-arid in the Northeast. And the economic activity is not as fruitful as in the other areas of the country. And the Midwest, the center region in Brazil, is the agricultural frontier. So in terms of agriculture, is the one of the most developed regions. And the south and southeast are the most urban, but the south is also very agriculture oriented, where we have like the wine wards and also soybean, very important ports. So we have in Brazil this mainly, of course, it's very it's in a nutshell, but we can say that we have like this north and south heterogeneity in the country that will be how can I say that, even more pronounced with climate change. So all the papers that we calculate climate change effects, we find the deepen of these inequalities within Brazil.
Wow, very interesting. Anyone has any other questions?
I saw here that Alejandro mentioned a group, the Women in Environmental Economics for Development. I didn't know about that, but I became very interested on that. Alejandro, I don't know, I received so many emails. Maybe I have received and didn't notice that. But I definitely am interested on that.
Yeah, that's good to hear. Well, first, thanks for your seminar. It was really interesting, your paper. I really like it. And yeah, we call this We Need. It's one of the groups from the Environment for Development group. And yeah, one of the things that they are actually doing is kind of network activities and kind of empowering women in environmental economics, so that more women are actually working in academia and encouraging them to publish. So it's very good to hear that this is something you're interested in, because we will for sure keep in touch with you. And now I see that Maria del Pilar just turned on her camera. She's the director of this program.
Oh, great.
EfD Colombia. So Maria del Pilar, if you want to say something.
Yeah, well, Paula, thank you so much for the presentation. It was great. And yeah, definitely we want you to be part of our group. So we're going to be in touch with you.
Great.
yeah, to kind of like, I'll email you explaining everything.
Okay.
But yeah, your work is exactly what we're looking for, and your profile as well. So thank you so much.
Great, Maria. I'll be glad to talk to you. And I also coordinate here in my university the Brazilian Women in Economics group, which is the BWE. But we have an economistas with a big A.
That's great. Absolutely great.
We do mentoring programs. We collect data from the participation of female during all the economic career. So I'm very, very engaged in the gender agenda too.
Amazing. Great.
I'll put we also have a podcast that we interview only female economists. It's in Portuguese, but we do have some foreigners interviews, but I'll put everything here in the chat.
Great. I mean, I think that's great, especially because we're actually building up what we need is planning to do in the next year. So I'm pretty sure your inputs will be great, and your experience in Brazil as well. So
great. So here's the website of the group. We have an English version, and the podcast is all in Spotify and Anchor, and together with Laura Carpusca from INSPER, which is another institution here. I run the podcast with her. We'll be glad. I'll be glad to interview some of you too.
We're doing a lot of work here in Colombia as well. In Los Angeles.
We get
women in economics as well, and also like we're actually increasing our research agenda in gender. So great.
Okay, so let's talk. Let's definitely talk. Thank you very much.
Yeah,
Thank you.
That's good. That's great. I'm glad we were able to make this connection between the things that you're doing. I didn't know that you were so involved in the gender stuff. So
that's exactly what we're looking for, Alejandro.
Yeah, that's right.
We were talking this morning about this. So
yeah. Okay, so thanks everybody that's still with us, and well, I'll email everybody, but we have Francisco Costa from University of Delaware next month. So I'll send the email when we have the details. And yeah, thanks, Paula. It was great. Thanks, Juliana, for your help, and Maria, Luis, for your questions. So thanks, everybody.
Un abrazo, Luis.
Lo mismo. Chao.
Thank you.
Thank you. Gracias.
Ciao. Thank you, Paula.
Ciao.
Bye, Alejandro. Bye,
Marcelo, bye.
Maria. Ciao.